So hi guys, in this video I'm going to go over the 11s project, which builds on the work we did in chapter 3. There's not too much new stuff here, so it should be fairly easy. And you have until next Monday to simply complete the card class, which I've sent you the template for. So the 11s is it's a solitaire game. I've got a jar file, which I've sent to you right here. The way you open it is you right-click on it and do Open with Jar Launcher on a Mac. I think on a Windows machine you can just double-click on it. So, nope, I lose right away. So restart. There we go. So why did I lose right away? Because there was no combination of cards, of non-face cards that added, 2 non-face cards that added up to 11, and there was no Jack, Queen, King. Those are the 2 ways you replace cards, either clicking on a Jack, Queen, King, or 2 cards that add up to 11. Okay, so here's our 11 replace. And since there are none others here, you lose. Let's just try it one more time. Ace and 10 is 11. Ace and 10 again is 11. And here's our Jack, Queen, King, right? Jack, Queen, King, replace. And we could keep going. But 8 and 3 and 8. I'll stop. Come on, stop. Replace. And so I'm down to 34 undealt cards, and the idea is to go through all the cards. And all the times I've tried this, I haven't gotten very far. It's a really simple-minded game to play, but kind of fun to program. Which is what we're going to be doing over the course of this year. So enough with that. So let's look at what I sent you. I sent you the template for the card class and a card tester file. It should be very familiar to you, this pattern, right? The card tester class will make a bunch of card objects from the class and then test them. So let's look at this. So a lot of comments here, which makes it seem like there's more than there actually is. We have 3 instance variables: suit, rank, and point value. We have our constructor, which takes in a string for those 2 strings for the rank and the suit, and an int for the point value, and is obviously going to take those parameters and move them over into these fields. That's easy. We have accessor methods for the suit, for the rank, and for the point value, right? So that we can supply the information of what the card is to other classes, other objects that need to get that information, right? Matches we'll come back to in just a second. ToString is an overridden method. It's actually a method of the object class, which is the superclass for all other classes in Java. And to override a superclass method, you have to use exactly the same header. So this is the header for the object class's ToString method. And the @override here is just to remind you that you need to you're overriding a method, so you need to use exactly the same header if you want to do that. And all you do in ToString is you usually just put together the fields as a large string and return that. So it would be something like return suit plus space plus rank plus space plus card value, point value, okay? Should be really easy for you to do. Okay, let's look at matches. This is where things get a little bit interesting, and there's some significant new things that you haven't worked on before. So basically, here's the issue. Strings are objects. Objects cannot be compared with a straight equals equals sign because they're complicated, right? A string is actually, it's not a simple thing like an integer or a double or a character or a Boolean value, all of which are known as primitive values because they're very simple. A string consists of a bunch of characters, right? And the number of characters can vary. And for those of you who know a little bit about programming, those characters are actually stored in a thing called an array or a list, right? And so we have to compare each of the elements of the list, each of the characters of each string to see if the strings are in fact identical. So what happens is that objects, classes, will define an equals method that can be used to compare, to return true if two objects of the same class are identical. And the string class, in fact, has a equals method. So we have two strings here. So what we're going to do here is do this in one line. You could do that with if statements, but this is by far the easiest way to do it. We're going to return. So we have suit and rank are our two strings. So this is also a good time to introduce the keyword this. See how it turned blue? It's a keyword. This is a keyword that says that basically it says this object, this object. You don't actually need to put this dot in front of the fields of the object that you're working with, right? So I could do just suit like that, right? Because what I'm really talking about here is the field suit of this object. But it's a good practice to get in the habit of writing this dot suit means this object's suit field. Okay? If this dot suit equals there's that equals method. Now we need to compare it to another string because this dot suit is a string. So we have passed in as a parameter to this method the card object called other card. So how do we get other card's suit out of it? Well, we call its accessor method, which is called suit, like that, right? So that actually returns the string that's the suit of the other card. And now the equals has a string, because that's what this all evaluates to. This evaluates to a string. And that's what equals wants as a parameter. And now this whole thing will return true if the two suits are identical. So if they're both like hearts, okay? Now, that's only one part of the card. We have two other fields which we have to compare. So we're going to use the AND operator here. And now we have to compare the rank. Oops, I will do that with, I'll press return here so you can see that, which is fine. And it's not suit this time that we're this dot rank. So this object's rank field, if that, which is a string, equals the other card's rank field, which is also a string. If both of those are true, right, if this evaluates to true and this evaluates to true, and, sorry, I will go down, and this dot point value. Now what is point value? Point value is an integer. So we don't need to use equals. We can just use equals equals because integers are primitives, and you can use equals equals with primitives. So if this card's point value field equals the other card dot point value. Now here, watch carefully. Right here, I use parentheses. Why? Because in this case, I have direct access to, because it's this object's field point value that I'm working with. I don't need to call the accessor method. I could, but I don't need to. I have direct access to it. On the other card, I do not have direct access to it, this other card. So I have to use its accessor method, which is called point value, right, with the parentheses. Okay, so a little bit tricky there, but no big deal. And I think that's good. And so if this is true, if this card's suit equals the other card's suit, if this card's rank equals the other card's rank, if this card's point value equals the other card's point value, then this whole expression is going to evaluate to true, and it will return true. Okay? So quite a lot going on here. So make sure that you understand this, but you should be able to that should be enough for you to do this. Okay? So finally, I wanted to just mention rank, because it's a little confusing. What is the rank of a card? Well, here's how to think of it. The rank is sort of the textual name of the card. So the 2 card, the 3 card, all the way up to the Jack, Queen, King, Ace. Okay? Now, the point value of each of these should be, will depend on the card game, right? So in this particular card game, all the number cards plus the ace have their, what you would consider to be their normal values, right? So ace is 1, ace has a point value of 1, ranks, and all these have their point values that are exactly equal to their rank. Jack, Queen, and King, in this case, have point values of 0, right? Because they cannot be used to get the 2 cards that add up to 11. They can only be, the only way they can use them is if they are a Jack, Queen, and King that are simultaneously on the board. Okay? So that's the way to think of ranks. But for the card, you just have to, we'll get into that as we move to creating a deck. If you read ahead in the PDF that I sent you out about the 11s game, you'll see that the next project we'll be working on for this 11s is a deck of cards. But for now, that's all you need to know. And yeah, so I will just leave this here because this may be something that you want to be able to look at while you are working on the matches method. Okay, thanks.